Okay, so on numbers 59 and 63, you had to take your standard form, change it to trig form, and then multiply or divide. Do you think that saved you much time? In your opinion, do you think it was more efficient than just doing the multiplication or the division? Maybe about the same amount of work? Okay, they were nice numbers, so you got nice angles, right? So, you know, it's probably debatable whether taking a product, changing it to trig form, and then multiplying is faster or not. Okay. Today we're going to talk about powers and roots, and this is like hands down way easier in trig form. Okay. You know, multiplication and division, maybe kind of even. This for sure is going to be way better in trig form. All right. Let's think about this. Here's our just plain generic number, z equals r cosine theta plus I sine theta. Let's talk about z squared. What does it mean to be z squared?
All of that squared, or all of that is a square root.
You were right with the squared. But what does it mean to square a number?
Multiply it times itself.
To multiply it times itself. So let's talk about how we would multiply z times z. When we multiply, what do we do with our r's? Okay, so if we multiply z times z, we would do r times r. Do you agree? Okay, and what would we do with our angles? We would add them, so we would add theta plus theta. Do you agree? Okay, let's talk about z cubed. What does z cubed mean? Z times z times z. Could you say it's the same thing as z squared times z? Right? Okay, so let's take z squared times z. When we multiply our r's, we get r cubed. When we add our angles, what do we get?
3.
Oh. Okay. Z to the fourth is the same thing as z times z times z times z. Could we say that it's z cubed times z? Right, because that will give us 4 z's. So let's take z cubed times z. When we multiply our r's, what do we get? R to the fourth. When we add our angles. Huh. Does anybody see a pattern? No? What's our pattern? Okay, whatever its power, what happens with r? R gets that power. What happens with our angle? It gets multiplied by that number. Great. So, if we have a number raised to a power, we are going to take r to the power, and we are going to multiply the angle times that power. That's it. Once again, you want your angle, your final answer's angle to be between 0 and 360. So you'll want to use your knowledge of coterminal. Ready for an example? Okay, are you going to write 12 of these in FOIL 11 times? No, you are not going to want to FOIL 11 times. Okay, do not try to do that on the test. Instead, we have a very nice way to take numbers to a power if they are in trig form. So let's go ahead and put this number into trig form first. Okay, so -1 plus radical 3i would be here. What is our r value? Two. Okay. Why do I hear a calculator still? We don't need a calculator. Because we have the tangent of theta is radical 3 over 1. When is tangent radical 3? 60 degrees, right? Okay. And it's negative in the second quadrant, so what's theta? 2 pi over 3 or 120 degrees, however you'd like to think of it. Okay. So our number is 2 times cosine of 120 plus I sine of 120. And that is being raised to the 12th power. So now what we can do, this 2, what do we do with the 2? 2 gets the 12th power. And what do we do with the angle? Okay, so what's 120 times 12? Yeah. What's 2 to the 12th? And our coterminal angle. 0. Now, what form was our original problem in? Standard, which means our answer should be in standard form unless they say otherwise. So, hey, that's not so bad. Our angle is 0, right? What's the cosine of 0? 1. So we have 4,096 plus what's the sine of 0? 0. So we have 4,096 plus 0i. That took us all of about 4 minutes, maybe? Can you imagine foiling 11 times? Okay, and how much room is there for error when you're multiplying 11 times as opposed to this regimen? Okay. So you all have problems like this in your homework. Are there any questions? I believe, let me check your homework here. Okay, so they're gonna want your answer in standard form. I believe there's only a couple times where you don't have a nice angle. Most of the time you're gonna have a nice angle. Okay. All right. Now let's talk about roots. What do I mean by root? Okay, but when I say the root of a number, okay, so the sixth root of a number, what is the square root of 1? Okay, let me rephrase it. Let me rephrase that. When we talk about roots, okay, if I'm talking about the square roots of a number, okay, if I'm talking about the square roots of 1, what numbers get squared to equal 1? Right? Negative 1 squared and positive 1 squared would both equal 1, right? Okay. Now, if I ask you for the sixth roots of 1, well, we know 1 to the 6th is 1, and negative 1 to the 6th is 1. But there's actually 4 more that are imaginary. Okay? There is a number. There are numbers raised to powers. When we find roots, some are real, some are imaginary. Okay? We've never worried about the imaginary before, but we can find them. Okay, so for a positive integer n, the complex number has exactly n distinct nth roots given by this formula. And this formula has a name, and I'm not going to say it right. If anybody's in French, you could probably help me out. Anybody take French? Okay. Let me. You do not have to memorize this.
Oh, God.
But you should probably write it down so you can use it in your homework. Write it down and we'll talk about it, okay? Okay, how do you say this, guys? Demois? Yes. Okay. This is Demois' theorem. Okay, so write it down and I'll explain what the K is.
Do you understand zero? All right. You add 0, 1, 2, 3, 4, 5, 6.
Okay, so basically, if I ask for the 6 roots, you're going to give me 6 numbers. If I ask for the 4th roots, you're going to give me 4 numbers. If I ask for the 12th roots, I wouldn't, but you would give me 12 numbers. Okay? You're going to use this formula over and over and over. You're going to begin by plugging 0 in for K, and then you'll plug in 1, and then you'll plug in 2, until you have the number of roots that you need. Okay? So if I ask for the 5th roots, you would start by plugging in 0, and then 1, and then 2, and then 3, and then 4, and you have 5 numbers. Okay. Now, let's talk about what's happening here. Okay? Whatever your R is in your trig number, you're just going to take the root of that here. Then for your angle, theta is whatever your original angle is. You're going to add 2 pi k, or if it's in degrees, 360k. And then you're going to divide by n. N is whatever root they're asking for. Okay. We're going to do a couple examples so you will see what I am talking about. Okay. You are going to be given this formula, so all you need to do is know how to use it. Okay. Okay. So we're going to start off easy. We're going to talk about the square roots of 16 cosine 60 plus I sine 60. Okay. How many square roots will there be? There will be 2. We are going to start with k equals 0, and then we will end with k equals 1, and that will find us our 2 numbers. Okay. So, let's start with k equals 0. The first thing we need is the nth root of r. So if we're finding square roots, then we're going to talk about the square root of r. Do you have a question? Well, k we're going to start out at 0, and we're going to increase k for each root that we find until we have the number of roots that we need. K is basically just going to adjust our angle for us. Does that help? Sort of. Okay. Basically, k is breaking up our 360 degrees into even slices so that we can find all of the numbers that are the roots. Okay, so by taking theta plus 2 pi k over n, it's giving us these equal slices to where we're finding those, in this case, 2 numbers. Okay. So we've taken the square root of 16, right? So now what we're going to do is we need theta plus 2 pi k over n. Okay, if you're in degrees, 2 pi is 360, right? So we have the cosine of our theta is 60 degrees plus 2 pi k. Well, if k is 0, that's going to be 0 over n, which is 2, because we're finding the square roots. So what's our angle? Our angle is 30. So we have 4 times the cosine of 30 degrees plus I sine 30 degrees. Okay. So our first square root would be 4 times radical 3 over 2 plus 4 times 1/2 I. Okay. So if you square this number, 40 should get that. Okay. Now let's find the second one. We're going to increase k, so that's going to affect our angle inside. Okay, so now we still have the square root of 16 times the cosine. This time k is 1, so we're going to take our theta, we're going to add 2 pi k, or 360 times k. Since k is 1, we're going to add 360 divided by 2. What is 60 plus 360 divided by 2? Okay, so we're talking about 4 times the cosine of 210 plus I sine of 210. Okay. So our number, the cosine of 210 is negative radical 3 over 2. And the sine of 210 is negative 1/2. So there are our square roots. If we square those two numbers, we will get back to z. Let's talk about something that's maybe a little bit more meaningful. Let's find the sixth root of 1. How many will there be? There will be 6. Okay. First of all, this number is not in trig form, is it? No. So we're going to need to put it there. Here is 1 plus 0i. What is our angle? 0. What's our r value? Okay, so this is 1 times cosine of 0 plus I sine 0. So to find our sixth roots, we know what two of them are going to be, don't we? We know we're going to get a 1 and negative 1. We should. Okay, the other four are going to be imaginary. That's what's going to happen. So our formula. Okay, we're going to start out with k equals 0. All right, so we're going to take the sixth root of 1 times the cosine of our angle plus 2 pi times k over n. What's 0 plus 0 divided by 6? Okay. So is everyone okay? Here's my calculation. I just adjusted my angles here to save some room. Is that okay? All right. So what's the cosine of 0? 1. So we have 1 times 1 plus 1 times what's the sine of 0? 0. All right. That's good. We knew we would get that for one of our answers. Okay. Let's talk about when k is 1. Then we have the sixth root of 1 times the cosine. Our original angle plus 360 times k divided by n. What does that make our angle? 60. Okay, that's a nice angle, isn't it? So the sixth root of 1 is 1. The cosine of 60. 1, so we have 1 times 1/2. Plus, what's the sine of 60? There's our second root. If I take that number to the sixth, we should get 1, because it is a sixth root. Let's talk about k equals 2. Okay, now k is 2, so we have our angle plus 360 times 2 over 6, which makes our angle what? 120? Okay, so we have 1 times the cosine of 120. What's the cosine of 120?
Negative 1/2.
Negative 1/2. Plus 1 times the sine of 120. We take that number to the sixth, we should get 1. All right, hey, we're halfway done. Woo! And we still have a couple minutes. Do not panic. 6th root of 1 times the cosine of our angle. Now we're talking about 360 times k, which is 3. So what's our angle? 360 times 3 divided by 6. Huh?
180.
What's the cosine of 180?
-1.
So we have 1 times -1. Sine of 180 is 0. There's our -1 that we knew we'd get. Okay? Then we plug k is 4. Then we plug k is 5, and we get the other two. Okay? Is the formula that difficult? No. But I will tell you, if you do not practice using this formula, it is going to be trouble on the test in 2 days. You have to do your homework tonight to practice using that formula. All right? Have a wonderful Wednesday. Make sure you get the skip 95. I didn't write that up on the board.